Hey everybody, this is Casbaro. Found the video is missing. So here is the 2-1 piecewise functions. This right here is an example of a type of piecewise function. It's called a step function because from this point to this point, you're at 15%. But then when you go to the next point, from here to here, you jump up to 28%. And each one of these jumps for the next interval. And that's what you're dealing with from here to here is an interval that comes up to the y value of 15%. So that's what piecewise functions are, is they are defined in a certain manner for a certain interval. Do you remember a game when you were a kid, you would drop a little thing and it would ping, ping, ping around? That's kind of what the piecewise functions do. Anything that is less than or equal to -2 right here would fall in this slot. Anything that is between the interval -2 and 3 would fall in this slot, and you'd evaluate it based on here. Anything that is greater than 3, 4, 5, 6, 7, would fall in this slot. And that's usually how I think of it in terms of evaluating. Here's another way to look at it. What I've got down here at the bottom, even though we can't see it, I needed to leave a little space. It says what is happening on the fences. Each one of these fences is the cutoff point for these two graphs. This would be the -2, and this would be a 3. Now on the fence, that -2 can go here, or it can go here. And it kind of it's back to where you were trying to determine if something was a function or not. When it falls on this side, it's got a line under it equal, and that means it's a closed circle. When it's on this side, there's no line under it, so it's an open circle. That's important because remember when we were talking about functions, you couldn't have 2 points at the same x going to different y's. So one of these -2's will go here, and the other one will go here, or something like that. But you won't cross it twice. It'll still be a function. All right? So let's look at what we've got here. We've got the -2. This one owns the fence because it's got the equal sign. This one does not. It just uses the fence. This one over here has an equal sign, so it owns the fence to the right. This one is open, so it doesn't own it, just uses it. So everything that we've got for -2 down goes here. So -2, then -3, then -4. But no matter what you put in, it's going to come out as a 1. So this is going to come out just 1, 1, 1. Okay? So if you were graphing that, you would have your -2. It's at 1 and it's colored in. -3 at 1. -4 at 1. And it keeps going forever. That is the first piece of this graph. The second one is just good between the intervals of between the numbers -2 up to 3. It's only good in there. So if you were trying to find out what numbers you've got, it would only be good between -2, -1, 0, all the way up to 3. When you get these, you would put them into here. -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. And 3 plus 2 is 5. So if you were graphing this piece, you're going to have -2, 0, And remember, it's open. Okay. -1, 1, 0, 2, and 3, 5. And that's closed just like it is over here. Okay, so this is the second piece of your graph. And on the next slide, we're going to put it all together. Right here, we're only dealing with values that are bigger than 3. So you can have 3, 4, 5. You can get as big as you want to go, but it's going to go forever because it just says bigger than 3 and it doesn't stop. So right here, you'd put it into this house. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. And like I said, it just keeps going on and on. This one starts at 3, goes to 6, and it's an open circle, just like we've got here. The one at 4 goes to 8, and the one at 5 goes to 10. And that gives us a little idea of where it's going, and it's going to go off forever like that. So each one of these yards with the fences has a different piece to play. That's not what it looks like, though, when you do it, when you have a problem that you're supposed to work. It's going to look like this. It's 1 if it's less than or equal to -2, just like we had it set up on this last slide. It is x plus 2 if it's between -2 and 3. And it is 2x if it's greater than 3. So you've got the same thing that we had here. It's just all put together in math writing. So when we had that -2, and it was stuff that was less than -2, so we had like -4, -3, -2. I want to make sure this is all coming up the same way. Everything came out 1s. Okay? Now, this is where it was 1. I can't go beyond this. That's done. Okay? Stops at 1. That means it stops at -2. The next one we've got, okay, it doesn't start until -2. I can't do -4 and -3 into this function. I can only start at -2, just like here. So, at -2, we ended up with 0. And I did 1 and 0, and then I jumped to 3. Okay. Still can't do anything in the first one. It's just too big. This one is only good between here and here. After that, after the 3, it stops. I can't use it anymore. So we had 0, 1 plus 2 was 3, 0 plus, oh, sorry, it was -1. -1 plus 2 is 1. Thought I had jumped wrong. -1 plus 2 is 1. 0 plus 2 is 2. And 3 plus 2 is 5. So we've got our points for the next graph. This last one, 2x, cannot start until 3. So we can't put anything here until we get to 3. Once we get to 3, we can do whatever we want to. There's 4 and then 5. And we can do that just fine. So 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. Just like what we got over here. We just didn't put it in 3 separate places. We put it all in one location. But the graph is identical, just all on one graph. -4 up to 1, -3 to 1, and -2 to 1. And remember, that's solid here, it's open here, solid here, and open here. So negative 2, 1 is open. Solid, sorry. Goes down in this direction. The next one, negative 2, 0, that's the one that's open. Right here. Negative 1, 1. 0, 2. And then I jumped up to 3 and 5. And that was closed in. Oops. Closed in. And that's where it stops. Then my last one I had 3, 6, which was open. 4, 8. And 5, 10. We drew it out just like this. So, those are your 3 graphs, just like we did over here when we had them all separated. All on the same graph together. Okay? So, I'm going to stop right there. That's 11 minutes. That's plenty of time. And we will start on another one shortly.